Uh, this is 2024 midterm exam practice question. I will be recording them, but I will not be opening any database screen since this will be a handwritten exam. Therefore, we will not have any database database connection and graphical user interface while we are solving this question. Please write 2 open source and 2 commercial enterprise database names below. Since it is saying commercial enterprise, you can write others, but for the first one, let's say this will be the answer. My courses, course database, and we have these 2000 midterm exam practice questions. Let's say this one to the midterm question exam answers. Okay, the first one you can write, for example, open source, and then SQLite is open source. We are using it. MySQL, then maybe both. Yeah, then commercial, and we are using Oracle and SQL Server. This is it. Let's go to the second question. This is this part. Okay, you should write SQL is the abbreviation of the structured query language. True, or maybe for this one I should put the writing here and put as an image, maybe, since I will be putting this part. It's okay, and let's save it, or something like this one, maybe. Okay, latex online tables. This one I'm missing this one. Okay, file, paste table data, paste. Okay. SQL is the abbreviation of structured query language. True. SQL language contains sub-languages such as DDL, DML, DCL, and TCL. Okay, here we are saying such as, contain, since it is an example. True. SQL is based on relational data model and set-based declaration. True. SQL queries allows and quick, efficient retrieval of large amounts of records from database. True. SQLite is a commercial language. False. A table cannot have a relation to itself since it will cause an indefiniteness. False. We have seen this self-join. A comparison with the null can be meaningful done with equals and not equals separated. False. We are using is null in the as a being of sublanguage of SQL, DML has a select, insert, update, and delete operations. Okay, here data manipulation language is this select. Data query language has select. Therefore, for DML in our course, at least we said insert, update, delete, and this is false. Open source databases are for uses for enterprise companies. We have talked about it. This is false. A lot of enterprise companies are using open source databases. GUI tools are only way to access databases. False. And this is it. Okay. I will be putting this one. Let's say markdown, close. This is our generate copy. This is the second answer. Okay, let's continue. Close this one, and we are continuing with the question 3. Simple ER diagram, 20 points. Please draw a simple ER diagram for a university course schedule system. In your system there will be departments, faculty members, professor, courses, classes, and offered courses. Please mark 1 to 10 relations. So in your ER diagram, your diagram needs to include possible columns for understanding relations between tables, but does not need to include every possible column. Okay, but I'm asking that only give some columns and at least give these entities or tables. Then we will have department tables, faculty member tables, courses, classes, and offered courses. This is, as you can see, 20 points since it will not be a short one. Okay, yeah, for this one normally you will write in the how can I say, you will write in the by hand, but I don't want to do this one. This is not our, but first of all, what are we saying? That we have these departments. Okay, then we have these departments. You can use all uppercase, you can use the others, but this is not the first, this part. Okay, let's say we have these departments. For departments ID, we can have ID, the others are not necessary. Then we have these faculty members. Okay, here, faculty members. I don't care about if this will be this way or not. That is not this important. Okay, and we have this courses. Okay, here courses, and we have this, let's say student here. Students. We don't need this one. We have these faculty members, therefore we don't need teacher. Let's see the others. Classes and offered courses. We have this. Classes. We have this. Courses. Classes. This will be courses. Courses, classes, offered courses. Then this will be the offered courses, let's say. Courses. Let's forget about the relationship for now. Then we will be, if you do not put in a relationship, we will see this part. You don't need to use this PK since I did not mention it. And then, for example, even this ID is not so much, but it asks for it. Okay, int ID. Normally I ask for the column. These data types I am not asking, therefore if you miss or if you do not include these data types, it will not be that important. But right now, since this course is relational databases, okay, you need to put some relations on it, and this is this notation of giving which have a one-to-one or one-to-many relationship. Okay, let's say we have this faculty members, and we can offer this one from documentation. Here, of course, you are expected to read a little bit about this, what they mean. That here, okay, customer places order, or this contains this order. Okay, here we are talking about which customer has one-to-many orders. Okay, and this is good enough. If you know this crawl notation, one-to-many, you can use it, and it will be enough for us. Okay, for example, but we need departments has classes. Okay, since these are the physical classes. Here I am doing something wrong, and here for example has. Okay, I need to write this has here, and here departments has classes, okay, and also department has courses, okay. Courses again one to many offered courses this semester. Again you can write has. And for faculty member teaches, since same class, for example this introduction to databases classes, some of you are repeating, you has taken this class from different department member, different faculty member, okay. Also department has faculty members, okay. Then department has student, it is not included. Did we talk about student here? Department, faculty member, courses, classes, offered courses, okay. Since I did not say student explicitly, you can include it or you cannot include it, but it's something like this with auto sync. No, this is has student teaching, and this is again has, okay. As you can see, has department has classes, department has courses, and ID. Here my second question again here say that you do not need the possible, but your diagram need to include possible columns for understanding the relation between tables. Therefore I am asking some tables in this diagram, some columns. ID is the only this one. You can rename them, for example classes ID to make them more understandable, courses ID, but normal ID is enough. Again offered courses ID, for example here departments ID, and here faculty members ID, and here student ID, for example. Then since this is a student ID, department here has this one, and here for student I should have a department ID to show which department I belong as a student. Every student has a, again I should have department ID for faculty member, and offered courses has a department ID, classes has a department ID, and offered courses or department has classes. No, department may not have classes, or I can say offered courses has classes. This will be better, I think. And then offered courses has a classes ID, and it changed. Okay, this is somewhat better. I do not expect it to be very fully correct, okay. This type of database designs has more than one answer, okay, but I expect something meaningful. Therefore this has, teaches, and offered courses taught in, for example this one, okay. Offered courses taught in classes. When I read this two relation, okay, department has faculty member, this is meaningful. Department has students, this is meaningful. Departments has courses, and also if you are using everything as with students, I mean everything is plural, use plural. Everything is single, use single, okay. It should be consistent. otherwise it is the reading is something is not meaningful. Okay, department has students, it is meaningful. Department has faculty members, it is meaningful. Department has courses, meaningful. Courses has offered courses, or courses taught in okay, since same course will be taught in different semesters. Okay, your classes ID, and for the offered courses the meaningful will be, for example, in year, for example, or semester ID, something like that, and this will be more meaningful. Classes offered, and since also faculty member teach this one, for the offerers we will have this faculty member ID, since we have this too. And classes taught in, okay, something like this is meaningful. This some of the columns may be missing, or features may be missing in the tables, but I expect something meaningful, and this is good enough. I will be putting this one as a diagram, and as I said, it should not be a fully 100% correct. A design database design questions has always something different, but here this is good enough. And mermaid, okay, for mermaid we are using this one, okay, and this will be our answer. Of course you will not be writing in mermaid, but you will be doing something like this as a solution, and this will be our question 3 as an answer. Let's continue. The others should be more easier. Okay, and here, fixed query, 10 points. Your coworkers come to you with following SQL query. He is trying to find customers whose first name start with A. Please fix the query so that way. Okay, it is easy. You need to write something like this one as a 4. Yes, question 4. And we know that first select, from, and where. And here the problem is this one. We are using this part. We cannot use with the equals. Okay, we need to use like, and this is the answer. Write SQL 10 points. Please write the SQL statement which will produce following result. Employee table is our Chinese employee table. Okay, I am asking how you can put this result. Here we have an employee ID and prior employee ID as before in this part, and this is null. Okay, you can write this one question 5 with joins, or you can write this one with subqueries. Okay, here I have here I know that employee ID, if I write this one, select employee ID, okay, and first name and last name, and table name is employee from employee. The subquery one is the easiest one. You can write something like this one, select minimum, select maximum employee ID, maximum employee ID from, again, employee, where we need to write alias here, and again we need to give a alias prior employee ID, prior employee ID, you can write as also here, as where e dot employee. This is P, this is E. We want P dot employee ID, we want E dot employee ID, we want E dot first name, we want E dot last name, and yeah, where E dot employee ID, this employee ID. Greater than this current P dot employee ID. Then it will try to bring us an employee. For the first one, for the row 1, it will not be able to find it. Therefore, it will bring us null. For the others, it will bring us win 1, 2, 3, and the others. And of course, this could be accomplished with the join, but that is harder. This is more understandable and more easier query. But if you write something with the join and I think that it will work, I will accept as an answer 2. You are working with the following address table: columns, address ID, street number, street name, city, postal. And here we have this null and attribute. Write an SQL query that fills the that retrieves all addresses but handle null values in the following way. If the street number is null, display no street number. Okay, street number can be null. Street name is null, display no street name is given. If city is null, display unknown city. If postal code is null, display NI. Your query return should all returns in the table while handling the null issues. Order by results by address ID. Okay, since it is saying return all columns in the table, we need to write all 1, 2, 3, 4, 5 columns in our select. And order by result as an address ID should be written. Okay, I am writing select. What was its name? Address ID. Address ID. Then again I am street number. Then street name. And then city. Then postal code. Postal code 1, 2, 3, 4, 5. It is there. Let's see. Address ID here. Street number, street name, Steve, and postal code. Okay, for street number is null, no street number. Okay, then this is easy with the Qualescate. You will write Qualescate. The street number, this one. Since I am asking as a result, this will be as street number. Since otherwise this will be shown and it is not very good. No street name is given. Okay, and here again Qualescate. No street name is given, and as street name. For city, unknown city. This is about only knowing Qualescate function. This question. As city. For postal code, again Qualescate. Postal code. And here it says NA. NA. And again as postal code. And table name is the address, and from address, since I am asking order by address ID. This is